Good afternoon, everyone. Welcome to the day 2 of Mathematics 21 LE1 review of MBAN 109. MBAN 109 is brought to you by the University of the Philippines Mathematics Major Circle in cooperation with UPMC, or the University of the Philippines Mathematics Club. So here are some reminders to maximize your experience in today's review. Prepare your note-taking materials or applications. We tend to forget things easily, so we recommend writing down notes from the review. Next, please keep your cameras and microphones off for the duration of the review. If you have questions during the discussion, you could put your questions in the chat box. Also, this review will be live streamed to the MBAN 109 YouTube channel for educational purposes. You may go back to the recording after the review. Next, this will be a 2-day review. Today is the second day. However, you can still view the recording at the MBAN 109 YouTube channel if you will not be available in one of the days. Okay, so let's start for the first problem. Our first problem is about the Rolle's theorem. So given the function f of x is equal to the arc sine of x when x is less than or equal to 1, but greater than or equal to -1. Well, equal to arc cosecant of x when x is greater than 1. Determine if Rolle's theorem is applicable to the function f on the interval I from 1/2 to 2. If so, determine all values of c such that f prime of c is equal to 0, where c is a subset of the interval I. So let's recall Rolle's theorem. The Rolle's theorem states that if f is first continuous on the closed interval AB and differentiable on the open interval AB, also if f of A is equal to f of B, then f prime of C is equal to 0 from some C such that C is less than or equal to A but greater than or equal to B. So meaning C is in between A and B. So yung solution for the given problem, we need to verify that f is continuous on the interval 1/2 to 2, differentiable on the open interval 1/2 to 2, and that f of 1/2 is equal to f of 2. Since arc sine x and arc cosecant x are continuous on the closed interval -1 to 1 and the interval 1 to the positive infinity, respectively, the only potential point of discontinuity is x is equal to -1. So, since yung mga intervals natin is nag-end sa parehas na 1 and sa 1, yung -1 to 1 and yung 1 to positive infinity, the only possible point of discontinuity is if x is equal to 1 lang. So let's try getting the limit of f of x as x approaches 1 to the left. So, ayan. Limit of f of x is equal to, as x approaches 1 to -1, is equal lang sa limit of arc sine x as x approaches 1 to the left. Equal lang siya sa f of 1 equal sa arc sine 1. Or equals sa pi over 2. Then, ang limit naman ng f of x as x approaches 1 to the right is equal siya sa the limit ng arc cosecant ng x as x approaches 1 to the right, which is equal lang din sa pi over 2. So since both limits from left and right are equal, masasabi natin f is continuous at x equals 1 and hence all over the interval I. Finally, we verify that f of 1/2 is equal to f of 2. Note that f of 1/2 is equal to the arcsine of x equals to pi over 6. Ayan. And f of 2 is equal siya sa arc cosecant ng x or arc cosecant ng 2, which is equal to pi over 6. So yan, f of 2 is equal lang din sa f of 1/2. So next, since nakuha na natin i-verify yung continuity niya, next naman natin i-verify yung differentiability ba niya. Note that since arcsine is differentiable on the interval 1/2 to 1 and arc cosecant is differentiable on 1, 2, the only point where f might not be differentiable is at x is equal to 1. So, ayan. Yung limit ng f of x as x approaches 1 to the left is equal lang siya sa limit ng 1 over the quantity square root of the quantity 1 minus x squared as x approaches 1 to the left. Since yung x natin dito nag-approach siya sa 1 from the left, yung x squared is kahit napalapit siya ng palapit sa 1, it will never be equal to 1, which is it will be actually equal to less than, will be equal to the or instead less than 1 siya. So dapat magiging yung radical natin is magiging greater than 0. So pero sobrang close niya sa 1, kaya yung x squared, magiging sobrang close siya sa 1. So magiging yung 1 minus x squared will be very close to 0. Pero magiging positive pa rin siya. So 1 over 0, as sobrang liit na amount which will be equal to the positive infinity. Kaya positive sign siya kasi yung yung denominator natin is still positive. Ayan. We can stop here. This is enough to verify that f prime of x does not exist. Ayan. One can verify that the limit natin from the right is also infinite or negative infinity naman, at also it doesn't exist there. So hindi natin siya kailangan ituloy. Hindi na natin kailangan ituloy siya, to be honest, kasi first first part pa lang is nakita na natin na yung limit ng f of x, yung f prime of x does not exist. So yan, we have shown that f does not satisfy the conditions of Rolle's theorem, and there is hence no need to find any points C on the interval I such that f prime of c is equal to 0. So we're done. In fact, there are no points on I such that f prime of c is equal to 0. Also, there are no points in the entire domain of f where f prime of c is equal to 0. Ayun. So, before we move on sa problem 8, meron ba tayong mga katanungan from our discussion sa problem 7?
Okay, for me, meron isa dito. Paano po naging range ng arc cosecant of x ang open close bracket 1, positive bracket, positive infinity?
Can you repeat the...
Okay. Paano po naging range ng arc cosecant x ang close bracket 1 tapos open bracket positive infinity?
Ito, dito ba sa part ito? Ay, dito po ba?
Yes. Actually, dapat feeling ko domain tinutukoy niya kasi based dun sa problem domain.
Yeah, I mean, I think domain naman siya. Hindi ba? Kasi T2 is continuous siya sa -1 to positive infinity. I mean,
Yeah, feeling ko medyo domain dapat tong 1 infinity. Bakit daw ito yung domain ng cosecant of x?
bakit siya yung domain?
Yes.
Kasi wait lang.
Hello, let me answer this question.
Ayan, thank you, Rowie.
Ang domain ng arc cosecant x is 1 to infinity. Malalaman niyo yon from your previous lesson. I think that's lesson 6 ata, na naka-indicate doon na yung mga domain and ranges ng inverse trigonometric functions, and then nandun din yung mga hyperbolic cosecant and inverse hyperbolic cosecant functions. So ayun, doon yung makikita yon. Check yun na lang.
Thank you, Rowie. Thank you for that, for answering the question. Aside from that, meron bang
Okay.
meron ba bang ibang tanong?
On my end, wala namang tanong. Just a reminder, guys, if you have any questions, please log in sa ating pigeonhole.at/BA59CB, all caps siya. Tapos, please follow yung format kung may general questions kayo or specific question dun sa problem na dinidiscuss ngayon. Kasi hindi na namin to babalikan pagka nasa next problem na tayo. So if you have any more questions, please do so before we move on to the next problem. Thank you. So far, wala naman.
Okay. So we can move on na sa next problem, sa problem 8 natin. Ayan. Problem 8, which is about sa mean value theorem. So fix C is greater than square root of 2. Determine if the mean value theorem is applicable to the arc secant of x minus the arc cosecant of negative of x on the interval I is equal to square root of 2 to C. If so, show that arc secant of C is greater than arc cosecant of C. Ayan, so recall natin, ano ba yung mean value theorem? The mean value theorem states that if f is first continuous on the closed interval AB, differentiable on the open interval AB, then f prime of k is equal to the difference of f of b and f of a over the difference of b and a. For some c such that a is greater than k, but k is less than b. But k is greater than b. So meaning k lies between a, b. Ayan. So ayan. Since trigonometric functions are continuous on their domain and inverses of continuous functions are continuous, we have that inverse trigonometric functions are continuous on their domains. Since I lies in the domain of arc secant and arc cosecant, both of these functions are continuous on I. Hence, arc secant minus arc cosecant is continuous on I. And to verify naman ang differentiability, note that on I, the derivative of arc secant x minus arc cosine x is equal to arc cosecant x, sorry, nagkamali lang, is equal siya sa derivative ng arc secant minus sa derivative ng arc cosecant. So ayan, sa property ng derivative, ayan, yung derivative ng difference is like difference lang ng derivatives ng bawat isa. So matutunan natin na yung derivative ng arc secant is 1 over the quantity absolute value of x times the square root of x squared minus 1. Tapos naman yung derivative ng arc cosecant is just the negative of the derivative ng arc secant. So kapag in-evaluate, makukuha natin is 2 over x times square root of x squared minus 1, which is defined on I since the denominator is not 0. Note that the absolute value of x is equal to x lang since yung x natin is positive. Siya ay greater than the square root of 2, which is in turn ay positive. So na-drop natin yung absolute value ng x dito since naman yung x natin is positive. Dahil sa definition ng absolute value of a positive number is just the number itself. Ayun. So we now know that the arc secant minus arc cosecant satisfy the conditions of MVT or the mean value theorem. Using the MVT on f is equal to arc secant minus arc cosecant x. In general, we get that there exists k such that in the interval I sub 1 such that arc secant minus arc cosecant of the derivative nila ng arc secant minus arc cosecant ng k is equal lang din sa f of c minus f of square root of 2 all over c minus square root of 2. Since ito kanina sa previous slide na-compute natin which is equal sa value ng 2 over k times square root of x squared minus 1. Then here, when we plug in ng value na f of c, equal siya sa arc secant of c minus arc cosecant ng c minus f of square root of 2, which is equal to the quantity arc secant square root of 2 minus arc cosecant square root of 2 all over c minus square root of 2. So ayun, magiging arc secant c siya minus arc secant c all over c minus square root of 2. Sorry. Kasi ang value ng arc secant next square root of 2 ay equal lang sa value ng arc cosecant square root of 2. So magiging 0 tong part na ito. So matitira yung part na ito. So by multiplying both sides, yung left hand side and right hand side ng c minus square root of 2, makukuha natin na 2 times the quantity c minus square root of 2 all over k times the square root of k squared minus 1 is equal lang sa arc secant c minus arc cosecant c. Note that the right hand side is positive, so the left hand side should be positive as well. That is, arc secant c is greater than arc cosecant c. Ayun. So yun, since na-show na natin siya, ayun, na-show na napakita na natin na yung arc secant c is laging greater than arc cosecant of c. So yun, nagamit natin yung application ng mean value theorem para mapakita siya. Ayun. May mga katanungan ba? Or like, may mga questions ba regarding sa...
Okay, so bale, for pigeon hole wala. And I made the change ngayon na you can try to ask me through PM kung hindi nyo kaya magtanong sa pigeon hole. Ayun lang. So we can proceed na sa next problem.
Okay, thank you. So next problem, problem 9. First derivative test naman siya. So let natin ng f of x is equal sa absolute value ng x minus 1 when x is less than 3. And sa equal naman siya sa negative x squared plus 7x minus 10 when x is greater than or equal to 3. Find the intervals on which f is increasing or decreasing and locate all relative extrema of f on the set of real numbers. So yun, recall natin definition. A number c on the domain of f is said to be a critical number of f if f prime of c is equal to 0 or f prime of c is undefined. So definition natin, let f be a function defined on an interval I f is said to be strictly increasing if f of a is less than f of b for all ab on the interval I such that a is less than b. F naman is said to be strictly decreasing if f of a is greater than f of b for all ab such that a is less than b. So ayan. Ayan yung definitions ng strictly increasing at saka strictly decreasing. Also, let f be a function that is continuous on, ang theorem naman natin, let f be a function that is continuous on the closed interval ab and differentiable on the open interval ab. If f prime of x is greater than 0 for all x on the interval ab, then f is increasing on the closed interval ab. If f prime of x naman is less than 0 or negative siya for all x on the interval ab, then f is decreasing on the closed interval ab. If f prime of x naman is equal to 0 for all x on the interval ab, then f is a constant on the closed interval ab. Ayan. Let f be a function continuous on ab which contains the number c. Suppose f is differentiable on ab, except possibly at c. So dapat si cf is differentiable on the open interval ab, except possibly at c. So pwede sa c siya, pwede hindi siya differentiable sa c. Then if f prime of x is positive for all x on the interval ac, and f prime of x is negative for all x on the interval cb, then f has a relative extrema at x equals c. If f of x naman is negative for x in the interval ac, and then f of prime of x naman is positive for all x in the interval cb, then f has a relative minimum at x equals c. If f of x naman does not change sign from ac to cb, then there is no relative extremum at x equals c. So, meaning lang nito, if f of prime of x ay positive dun sa first interval natin, tapos nag-negative naman siya sa ating second interval, then meron tayong relative maximum. Kapag naman yung f prime of x natin is nag-negative sa first interval, pero nag-positive siya sa second interval, meron tayong relative minimum sa x equals c. Kapag hindi naman nag-change ng sign from the first interval to the second interval, kunwari negative siya sa a to c at negative din siya sa c to b, then there is no relative extremum. Pwede naman positive siya sa a to c, tapos positive din siya sa c to b, then wala rin siyang relative extremum at x equals c. So ayan. Let's try the problem. Let g of x is equal to the absolute value of x minus 1. Notice that g of x, positive siya kapag greater than or equal to 1 yung x. Tapos negative naman siya kapag less than 1 siya. Thus the interval becomes f of x is equal to 1 minus x if x is less than 1. X minus 1 is kapag naman x is less than 3 but greater than 1, I mean. Equal naman siya sa negative x squared plus 7x minus 10 if x is greater than or equal to 3. Getting the derivative of f or f prime of x is equal to 1 kapag x is less than 1. Negative 1 naman siya if x is less than 3 but greater than 1. Equal naman siya negative 2x plus 7 if x is greater than 3 naman. In this interval, 1 is automatically not continuous since the derivative of f from the left of 1 is equal to 1 is not equal to negative 1. So since hindi parehas yung derivative na from left to right, from left and from right, then hindi siya continuous. So una pa lang, f prime of 1 is dne. So makikita natin, since from the definition of a critical point, f prime of c, dapat 0 siya or does not exist. So yung x equals 1 is masasabi natin siya isa siyang critical point. For x equals 3 naman, that was that the limit of f of x as x approaches 3 from the left is equal lang siya sa 2. And yung limit naman ng f of x or yung negative 3 squared plus 7 times 3 minus 10 equal lang din sa 2. Thus, f is continuous on x equals 3. Also, yung f prime ng 3 from the left is equal lang din sa f prime ng 3 from the right. So, ito siya sa negative 1. So, f is differentiable at x equals 3. Since f prime of 3 is not equal to 0, x equals 3 is not a critical point of f. When f prime of x is equal to 0, the only equation applicable is 0 is equal to 2x plus 7, which is dapat x is equal to 7 halves. So, x equals 7 halves is a point or isa siyang critical point. And pwede tayong gumawa from our nakuhang mga data. Pwede tayong gumawa ng table of intervals. So first derivative test natin sa interval ng negative from negative infinity to 1. Ang sign ng ating f prime of x is negative. Pag equal naman sa 1, ang sign ng ating first derivative is undefined. Sa ating interval naman na 1 to 7 halves, ang sign ng ating derivative is positive. When x equals 7 halves naman, ang sign ng ating derivative ay 0. Sa ating interval naman na 7 halves to positive infinity, ang sign ng ating derivative is negative. So, from the table, can be concluded that f has a relative minimum at x equals 1. Relative minimum siya since yung first derivative sa left side or sa interval negative infinity to 1 is negative. Tapos ang first derivative naman dun sa right side niya or sa interval na 1 to 7 halves is positive. So base sa dun sa ating theorem kanina, x equals 1 is a relative minimum or merong relative minimum at x equals 1. And dito naman, since x equals 7 halves is our critical point, at since nagbago yung sign ng first derivative natin before sa interval before niya from 1 to 7 halves and sa interval ng 7 halves to positive infinity, from positive to negative, base sa theorem natin kanina, meron tayong relative maximum at x equals 7 halves. So ayun yung nasagot natin yung tanong na yun, intervals natin from which f is increasing or decreasing. And the relative extrema of f, which are at x equals 1, meron tayong relative minimum. At x equals 7 halves, meron tayong relative maximum. Ayan. So, meron ba tayong mga katanungan about sa problem na ito?
Okay. Actually, walang nagtatanong. Kahit sa chat, wala nagtatanong.
Okay. Okay, so siguro before we move on to our next problem now, which is presented naman sa ating next speaker, maybe we can have a break muna for few minutes siguro. Ayun.
Hello. Nakikita ba yung nang maayos yung yung slides? Okay, thank you. So, hello, good afternoon. I am Daniel Miguel, or DM for short. I will be discussing today problems 10 and 11 about concavity and graph sketching respectively. So, problem 10, concavity. Let f and g be twice differentiable everywhere functions such that f of 69 is negative 16, f prime of 69 is 10, f double prime of 69 is negative 15, g of 69 is 24, g prime of 69 is 15, and g double prime of 69 is negative 30. Consider h of x, the function h of x equals f of x multiplied to g of x. Verify x equals 69 is verify that x equals 69 is a critical number for h. What conclusion can you draw for h of 69 from the second derivative test? Ngayon, let's recall what second derivative test is. Second derivative test states that if f is a function such that f prime and f double prime exists on some open interval containing x equals c such that f prime of c is equal to 0, then if f double prime of c is greater than 0, then f has a relative maximum minimum value at x equals c, or if f double prime of c is less than 0, then f has a relative maximum value at x equals c. Then f has a relative maximum value at x equals c, or if f double prime of c equals 0, then no conclusion can be drawn. So, we're asked to verify that x equals 69 is a critical number for h, that is h prime of 69 is 0. So, i-recall lang natin ang chain rule, ay ang product rule sa differentiation. Pag meron kang multiplication ng dalawang function f of x at g of x, ang kanilang derivative ay f prime of x, g of x, plus f of x times g prime of x. So let's substitute the values let's substitute 69 equals to x. So we have h prime of 69 equals f prime of 69 multiplied to g of 69 plus f of 69 multiplied to g prime of 69. Given dito yung mga values sa taas, may given na ang f prime of 69 natin ay 10, ang g of 69 natin ay 24, tapos ang f of 69 natin ay negative 16, at ang g prime of 69 natin ay 15. So 10 times 24 is 240, and negative 16 multiplied to 15 is negative 240. Add them together equals 0. So ano yung conclusion natin? Na h prime of 69 is equal to 0. So ngayon, gagawin naman natin, gagamit tayo ng second derivative test for h. But note that h prime of x equals d over dx of the quantity h prime of x or f prime of x multiplied to g prime of x plus f of x multiplied to g prime of x. So, mangyari lang dito ay so ang mangyayari dito ay magkakaroon ulit tayo ng ayun, so ang mangyayari dito, i-distribute lang natin tong d over dx. And then once again, the product rule for differentiation will be applied. So we then now have d over dx, f prime of x, then multiplied to g of x plus f prime of x multiplied to d over dx g of x plus d over dx ay d over dx f of x multiplied to g prime of x plus f of x multiplied to d over dx g prime of x. So yun yung nangyari. So una, in-apply muna natin dito sa unang term, hindi over dx, tas doon sa pangalawang term. Kaya magkakaroon tayo ng apat na term na dito. So ang resulta ay f double prime of x multiplied to g of x plus 2 f prime of x, g prime of x plus fx multiplied to g double prime of x. So we can write h double prime of h double prime of 69 in terms of the givens. So yan, pwede na tayong mag-substitute using our given. Finally, h prime of 69 is equal to this this entire thing here, f prime of 69 multiplied to g prime of 69, which is negative 15 times 24, plus 2 multiplied to f prime of 69 times g prime of 69, which is 2 times 10 times 15, plus f of 69 multiplied to g double prime of 69, which is negative 16 times negative 30. So I've evaluate this and then you get 420. So ngayon napakita natin na na-verify natin na ang h prime of 69 ay 0 at h double prime of 69 ay 420. So balik tayo dito. So lumalabas na yung na equal to 0 yung h prime of 69. So tapos tawag dito, yung h double prime of 69 ay greater than 0. Hence h of x has a relative minimum at x equals to 69. Okay. Ngayon, for problem 11, our topic is graph sketching. Sketch the graph of f of x equals x squared over Q&A muna, sige. Okay, George.
Okay. For questions regarding yun sa problem 10.
Yes.
Sabi raw ni Anonymous, paano po malalaman na i-multiply dapat yung f and g to get h dun sa problem 10?
Ay, ito?
Yes.
Ano siya, nakalagay lang siya, consider h of x equals f of x times g of x. So yun yung given mo. Hindi siya you don't need to tawag dito to think of it as a part of the entire process, pero part of the given lang. Hindi siya as in hindi siya yung one of the steps you have to remind you of yourself, pero siya yun yung given. Pero dahil ang given natin f of x times g of x, you have to remember what is the derivative of f of x times g of x. So yun yung dahilan kung bakit yun yung given, parang you were tested if you know your rules in differentiation rules in multiplication of two functions. Okay.
Ayan, okay na siya. So, bale, there are no questions na left here sa problem. You can now proceed. Thank you.
Okay. So, dun tayo sa problem 11, graph sketching. So, sketch the graph of f of x equals x squared over x minus 1. Okay, next. So, recall lang natin yung theorem on concavity. Let f be a function such that f prime of x exists on open interval AB. Then we have the following implications. If f prime of x is greater than 0 for all x in the open interval AB, then f is concave up on AB. Or if f of x is less than 0 for all x in open interval AB, then f is concave down on AB. So, paano ano to? Wait lang, draw. So, ang mangyari lang dyan, magdodraw lang ako saglit dito sa sa taas na bahagi. So, bale, masyado palang makapal. Ayan. Ayan. So, bale, meron kang given na, halimbawa, ito yung A mo, kasi ito yung B mo. Tapos, open interval. So, hindi yan, so, yun, open interval AB. Tapos, pag daw f prime of x mo ay greater than 0, concave up ka on interval AB. Or on open interval AB. So, yun yung sinasabi ng unang implication. So, ayun. Ganyan yung concave up mo, parang ayan, yung naka-face siya upwards. Yung at the interval open interval AB. Pero kung ano ka naman, kung yung f double prime mo ay of x is less than 0 for all x in open interval AB, then nakaganyan siya, concave down. So yung kumbaga may ganyan kang shape, tas nagfe-face down naman siya. Ayun. So, bale, ganun lang yung sinasabi ng theorem on concavity. So, we have the following definition. So, meron tayo, if graph of f of x has a point of inflection or POI at point P with the coordinates C, f of C, if f is continuous at x equals C, excuse me, and the graph of f changes concavity at T, Equivalently, there is an open interval A, B containing C such that f double prime of x is greater than 0 for all x in AC, in open interval AC, and f of double prime of x is less than 0 for all x in open interval CB, or f of x is less than 0 for all x in open interval AC, and f double prime of x greater than 0 for all x in open interval CB. So ngayon, ano naman yung ini-imply ng definition na yan? So meron tayong possible points of inflection. Yung meron tayong points of inflection, parang ang sinasabi niya lang ay pag meron kang open interval AB, tapos nasa pagitan mo ay C, ayan, tapos sinasabi dito, continuous dapat at x equals C, tapos nag-change ng concavity at P yung graph mo sa F. So ibig sabihin, yung point mo at CF of C, halimbawa dito siya, nag-change siya ng concavity. So ibig sabihin na it's either from A to C, in the open interval A to C, ganyan yung itsura ng graph mo. Tapos from in the open interval CB, ganyan naman yung concavity ng iyong concave. Hindi mali. Nasabi lang dito na itong sa unan yan na ayan, f double prime of x is greater than 0 for x in open interval AC. So ganyan. Tapos f double prime of x is less than 0 for all x in open interval CB. So ang magiging itsura niyan ganyan. So 'di ba tandaan niyo sa concavity na yun nga pag concave up yun yung itsura niya, pero pag concave down ganyan. So ito yung point of inflection mo. Kung mapapansin mo mula dito concave up siya at concave up siya, pero pagdating dito sa point of inflection mo, nagbago na siya na direksyon. What about the second condition? F double prime of x is less than 0 for all x in open interval AC, so nakaganyan naman siya. And f double prime of x is greater than 0 for all x in open interval CB. So ganyan ang itsura niya. So isipin mo lang siya na ayan, ganyan. Pero kapag halimbawa, ganyan yung itsura ng graph mo, tas ito yung C mo, and yung point P, hindi na siya point of inflection kasi kung mapapansin nyo dito, concave up, dito sa part na to, concave up, dito sa part na to, concave up pa din. So yun lang yung sinasabi ng theorem ng definition ng point of inflection. So next slide tayo. So continuation lang nung kanina, meron tayong theorem of point of inflection. So if point P at C, f of C is a point of inflection of the graph of the function f, then f double prime of C equals 0, or f double prime of x does not exist at x equals c. So, anong ibig sabihin nun? Kanina, 'di ba, teka. So, ang mangyayari diyan, halimbawa, meron ka ulit open interval AB, tapos nandito ka sa C. Tapos meron kang tapos ito yung point P mo, point P. Tapos given ito yung graph, ayan ganan. So ang mangyayari kasi diyan, ano, yun yung point na clearly point of inflection siya. So ibig sabihin, dahil point of inflection siya, f double prime of c equals 0. Pero remark na the converse is not true. Bakit? Let's say na we have a vertical asymptote at x equals c. Then we have concave up in from open interval AC, yung graph ay concave up, pero asymptotic siya sa C, sa x equals C. Tapos concave up din siya sa open interval CB, pero asymptotic din sa x equals C. Pero kung mapapansin nyo, hindi nag-exist si f double prime of x sa x equals c. I mean, ayun nga, hindi siya nag-exist. Hindi siya nag-exist yung hindi nag-exist yung f double prime of x. Pero ibig sabihin ba nun may point of inflection na sa sa x equals c? Clearly wala, kasi can you have a point in this asymptote? Walang point dito sa x equals c. So the converse is not true. So ang ibig sabihin lang na to, if f double prime of c equals 0 or f double prime of x does not exist at x equals c, the point P, f of c may or may not be point of inflection. So yun lang ha. So be careful. Pag point of inflection, ito lang yung doon ka lang makakapaggawa ng gantong implication, pero hindi mo pwedeng i-imply ito kung totoo to. So yun, tumuloy na tayo. Excuse me lang, inom lang ako tubig. Okay. So we have the following tips for graph sketching. Number 1, find first the domain of f and the intercepts. So number 2, compute for all of the asymptotes, horizontal, vertical, and oblique. Number 3, find the critical points and the possible points of inflection, or PPOI. Number 4, using FDT or first derivative test or second derivative test, compute for the relative extremas. So you need to recall again FDT and SDT for this problem. And then use the table of F prime and F double prime to check the behavior of the graph on the intervals and the point. And 6, you can now graph your function. It's fine if the graph is not perfect as long as you meet the basic conditions from the previous items. Next, yan. So here are our objectives for our problems, for the problem. Number 1, find the domain of f and the intercepts. 2, find all the asymptotes. 3, find the critical points and possible points of inflection. 4, construct a table of intervals of f, f prime, f, and f double prime. Then 5, sketch the graph. Firstly, we find domain of f. Note that f is a rational function, thus the denominator must not be equal to 0. So ang domain agad natin, dahil nga yung ano natin sa rational function natin, yung x squared over x minus 1, ang denominator natin ay x minus 1. So x minus 1 cannot be 0, implies that x cannot be 1. So we now know that the domain of f is x for all x in R sa x in R such that x equals 1 is excluded. Now we find the intercepts of the function. For the y-intercept, we let x equals 0 and have y equals 0 squared equals 0, 0 minus 1 equals negative 1. So 0 over negative 1 is 0. So on the other hand, for the x-intercept, we let y equals 0. So ang mga since x minus 1 cannot be 0, we can multiply. Ano lang ha, be careful. Be careful in multiplying of in equations. Wag kayo basta-basta magmumultiply sa equation, sa both sides ng equation ng isang variable kung hindi nyo patiyak na 0 yon. Kasi magiging algebraically incorrect siya kung ganon, or mag-divide by a variable. Pero dahil yun lang, malalaman nyo din kung bakit, kung isipin nyo mabuti, wag kayo basta-bastang mag-multiply ng variable on both sides of the equation kung hindi nyo pa sure kung hindi included dun si 0. Pero dahil yung x minus 1 natin, clearly, hindi dapat siya maging 0. So therefore, we can multiply both sides by x minus 1. So this implies that x squared equals 0 or x equals 0. So ang intercept natin ay 0, 0. So isa lang intercept natin. Next. So to find all asymptotes, ngayon for the vertical asymptotes, we will find the limit of f of x as x approaches 1 from the right, and limit of f of x as x approaches from the left, and respectively their limits are positive infinity and negative infinity. So ayun, kailangan alam niyo na kung bakit ganun yung limit. Kung gusto nyong i-exercise kung bakit, sige lang. So thus the vertical asymptote of f is x equals 1. So dahil parehong infinity yung nasa infinity at negative infinity yung yung dalawang limit. So meron tayong asymptote sa x equals 1. So for the horizontal asymptotes, we first note that x squared all over x minus 1 equals x plus 1 plus 1 over x minus 1. So bakit naging ganun? I-divide nyo lang yung x squared by x minus 1, and ayan yung lalabas. Yung expression na to. So ngayon, So ang mangyayari ngayon dito, halimbawa ganan, tapos meron kayong asymptote. Ang mangyayari kasi dyan, at halimbawa papunta sa positive infinity. So, at some point, mag-approach siya sa isang value ng y equals something. So, kaya ginawa natin x approaches to infinity. Parang ganun. So, mangyayari ngayon dito, ikukuhanin natin yung limit of f of x as x approaches negative. Limit of x plus 1 plus 1 over x minus 1 to negative infinity as x approaches negative infinity, and the limit of x plus 1 plus 1 over x minus 1 as x approaches negative infinity. So, yun lang. So, kukunin natin yung yung limit as x approaches negative sa papuntang infinity. So, kaya pala x plus 1 plus 1 over x minus 1, ginawa natin ganyan. Kasi tandaan nyo na, kapag kasi nag-substitute agad kayo ng infinity dyan, magkakaroon kayo ng indeterminate form infinity over infinity. So, ayun lang. Remember that. Okay? So, ayun. Kung ating papansinin, dapat pala to ay, kung doon nagkakamali, positive infinity dapat to. Ayan. So, at positive infinity, so ang mangyari dito, infinity plus 1 plus 1 over infinity, positive infinity. So, 1 over positive infinity is 0. Ayan, 0 from yung notation na yan, yung 0 plus yung yun din yung limits at infinity. So tandaan nyo din yun, kailangan nyo rin yun dito sa pag-graph ng rational functions. Okay? So tas ito infinity na yan, positive infinity. So positive infinity plus 1 is positive infinity plus 0 equals positive infinity. And kapag naman x approaches negative infinity, so negative infinity plus 1 plus 0 minus equals negative infinity. Dahil hindi sila pareho ng dahil hindi sila pareho ng baga ito hindi siya equal to dyan, or hindi sila same ng sign, kasi ang infinity ay hindi mo masasabi kung equal siya sa infinity kasi everything breaks at infinity. Pero hindi sila equal ng sign. So walang horizontal asymptotes. So ang mangyayari diyan, kasi ang mangyayari kasi diyan, dapat may ma-approach na y equals some constant yung horizontal asymptotes natin. So yun lang. Next slide. Erase ko lang to. Ngayon, hindi porket wala tayong horizontal asymptote ay wala na tayong oblique asymptote. So, paano ba tayo nagkakaroon ng oblique asymptote? So, nagkakaroon tayo ng horizontal asymptote pag yung degree ng numerator at degree ng denominator ay equal. Pero in this case, yung degree ng x squared clearly ay mas mataas sa degree ng x minus 1. So magkakaroon tayo ng oblique asymptotes. So alamin nyo kung ano yung behavior ng mga asymptotes nyo kapag yung degree ng numerator at degree ng denominator nyo ay tawag dito, ay nag-iiba, parang ganun. So ngayon, for the oblique asymptote, meron tayong f of x minus x plus 1 equals 1, ay minus x, the quantity x plus 1 pala, equals 1 minus 1 over x minus 1. Ngayon, kukuhanin natin yung limit nila at infinity, at positive infinity and at negative infinity. Tapos f of x minus quantity, limit of f of x minus quantity x plus 1 as x approaches infinity equals the limit of x as x approaches in positive infinity, ay the limit of 1 over x minus 1 as x approaches positive infinity equals 0. So yung f of x natin kanina kasi so ano siya, so 0 siya, tapos the limit of x as the limit of f of x minus quantity x plus 1 as x approaches negative infinity equals the limit of 1 minus 1 over x minus 1 as x approaches negative infinity equals 0. So dahil equals itong dalawang to, masasabi natin na ito na yan ay na y equals dito, diyan, ay yung y equals x plus 1 equal ay natin ay oblique asymptote. So yun, so next slide, kukunin natin yung f prime of x at f double prime of x. So yung f prime of x equals 1 minus 1 over the square of x minus 1. And f double prime of x equals 2 over the cube of x minus 1. So kung gusto niyo kuhanin yung first at second derivative ng f of x, I leave that to you as an exercise. Note that f of x is undefined when x equals 1. Also, f prime of x equals 0 when x equals 0 or x equals 2. So yun, kayo na lang din mag-verify kung bakit. Ngayon, thus, x equals 0 and x equals 2 ay critical points ng f. On the other hand, f double prime of x should not be equal to 0. Kasi, tawag dito, pag kasi yan, tawag dito, pag ito kasi, nag-0 ka dyan, so tas ito, minultiply mo both sides by cube of x minus 1, mangyari kasi dyan 2 equals 0, so hindi siya totoo. So hindi pwedeng maging 0 yung f double prime of x mo. Tapos undefined pa if na kapag x equals 1. Pero hindi rin kasama yung 1 sa x equals 1 sa domain of f. So walang possible points of inflection ang f kasi wala tayong values of f prime of x when x equals c, f double prime of x is 0. So ngayon, Ayan, ano na tayo? Table na tayo. So, meron tayong table of intervals for f, f prime, and f double prime. So, first, ang una mong gagawin, ang general rule dito, yung tawag dito, yung mga critical point mo, ang mangyayari dito ay yung mga critical point mo kumbaga sila yung magde-divide ng x mo into many intervals. So ang general rule diyan, kung may 3 kang critical points, may 4 kang intervals. Kung may 2 kang critical points, meron kang 3 intervals. I mean, hindi, ang ibig ko palang sabihin dito, kung may 3 kang critical points or kung meron kang 3 values ng x na critical, yung magiging critical point yung yung point P, C, F of C. Kung may 3 kang ganun, then yung total number of interval mo ay 7. So parang mangyari diyan 3 plus 1. So kung dalawa yung critical point mo, 2 plus 1. So kasi nga yung mga critical points mo yung nagdi-divide sa sa domain sa iyong domain ng x. So meron tayong open interval negative infinity to 0, tas x equals 0, open interval 0, 1, 1, open interval 1, 2, 2, and finally open interval 2, positive infinity. Tapos yan, ilalagay mo f, f prime, f double prime, tas yung conclusion. So clearly, nakuha natin kanina yung intercept, 0, 0, yung nag-iisang intercept. Tapos, at x equals 1, undefined siya dahil yun yung vertical asymptote natin. At x equals 2, kayo nang bahala kung ba't naging 4 yan. Tapos, ngayon sa f prime, hahanapin nyo kung positive ba or negative yung pag nag-substitute kayo ng value ng x within that interval, magiging positive ba or negative yung value na yon. So syempre lahat ng nakuha natin kaninang value of x na yung f prime of x mo ay 0, so 0 na ilalagay natin diyan. Okay, inom lang ulit ako tubig. Okay, to continue. So ngayon, ang gagawin natin, magko-compute tayo. So kuha lang tayo ng point. Meron ano yung f double prime natin ulit? Ang f double, ito yung ano natin, 1 minus 1 over x minus 1 squared. So mangyayari dyan, so let's try f prime negative 1, kasi negative 1 is within the open interval negative infinity to 0. So magiging 1 over 1 minus x square of x minus 1 so 1 over negative 1 minus 1 squared. So mangyayari dyan, 1 equals 1 minus negative 1 minus 1, negative 2, tas square nyo siya 4, tas 1 minus 1/4 is 3/4, which is clearly positive. So kaya positive yung nilagay dyan sa f of prime when yung interval natin, open interval negative infinity to 0. So mangyayari, yun yung ganun ka magko-compute. So, I leave to you as an exercise kung bakit yung negative sa 0, 1, sa 1, 2, at positive naman sa 2, positive infinity. Yan, pinakita ko lang sa inyo kung ano yung process ng ng pagkuha ng sign. Then dahil meron tayong yung f prime of x natin equals 1 minus 1 over square of x minus 1, undefined pa din yung f prime of x at x equals 1. Then we have f double prime. So ulit, we will use the interval negative infinity 0 plus x equals negative 1. So ano ulit yung, ayan, f double prime of x equals 2 over the cube of x minus 1. So gagawin natin f double prime of 1 equals 2 over 1 minus negative 1 minus 1 cube. And clearly, yung negative 2 siya, tas raised to 3, negative 8. So negative 1/4. Kaya naging negative to. And again, yung mga natitira dito, I leave to you as an exercise kung bakit ganyan yung nakuha. Kasi ganyan na din naman yung proseso. At dahil meron ulit x minus 1 sa denominator ng f double prime of x, undefined pa din yung f prime of x at x equals 1. Tapos ngayon meron na tayong conclusion. So dahil unahin na muna natin itong mga open intervals, tas tsaka naman pagkatapos nun yung mga critical points naman natin yung lalagyan ng na conclusion. So dito sa conclusion, sa unang interval, increasing siya kasi positive yung f prime niya, tapos yung f double prime negative, so concave down. Tapos dito naman, f prime is negative, so decreasing siya at open interval 0, 1. Tapos concave down dahil negative naman yung f double prime of x at open interval 0, 1. Tapos decreasing naman sa interval na open interval na 1, 2, dahil negative yung f prime, tapos yung f double prime positive, so concave up siya at open interval 1, 2. Tapos at open interval 2, positive infinity, f prime is positive, so increasing siya, tapos f double prime is positive, so concave up. Ngayon, dahil wala tayo kaninang na-determine na point of inflection, so possible points of inflection, therefore wala dito sa tatlong critical points natin na point of inflection. Kasi kung mapapansin mo, ito concave down, so therefore ito hindi siya point of inflection. Ganun din dito sa x equals 2. So hindi siya point of inflection kasi concave up ito, tas concave up dito, tas concave up din dito. Tas dito, kung papansin niyo, concave down to, tas concave up naman dito. So kung at first glance dapat to point of inflection, pero hindi siya pwede kasi undefined nga yung natin, undefined siya dito sa at x equals 1. So ngayon mag-i-sketch na tayo. Ayan yung itsura. So isa-isayin natin bakit naging ganon. So una, i-sketch natin yung y equals yung mga, so kung i-sketch mo siya, ganyan yung itsura niya. So ito, banda rito, concave down, tas concave down pa din, tas ito yung asymptote mo na vertical, ito yung asymptote mo na horizontal, na oblique, tas ito yung intercept mo, tas ito concave up, concave up. So yun, that's it. We are at the end of our discussion. So any questions?
Okay, sa end ko actually wala, pati sa Pigeonhole. So, just a reminder, may ano pa, may general Q&A pa mamaya. So, kung feel nyo hindi nyo pa natanong yung kailangan nyo tanongin, you can just ask later. Ayun lang. Thank you.
So yun, once again, I am Daniel L. Miguel, and it's been a pleasure to discuss to you the last two topics, SDT, concavity and graph sketching. So yun lang. Thank you.
Okay. Thank you, DM and Alan, for discussing for today. So now I'll be turning on my cam, and now let's discuss on the general tips and tricks na we provided para sa exam bukas. So let me try to share my screen. Okay, yan. Change background muna tayo since nasa bahay. Okay, wait lang. Set up ko lang. Sorry, medyo may technical difficulties last night. Okay, let me share my screen. Give you slideshow. Okay, so bale, meron tayong tips before exams. So meron, actually may 3 parts in ito. Tips before exams, tips during exams, tas tips after exam. So let's start with the first tip. Ay, wait, but ito, sorry. Sorry guys, sorry, may ano lang. Ayan, tips before exams muna tayo. So my first tip is, ba't naggaganito? So my first tip is ito. Okay, so first is the exam is closed notes. So you must have reviewed properly before the exams. So bale, we told this na rin nung day 1 in general na closed notes ang exam. So dapat you have prepared yourself already before taking the exam. So yung ibang tips pala rito, just a heads up, they are already answered during day 1. Pero ito para ma-recall natin general tips. So next, always answer exercises and ask your instructors to check your work so that you can study more effectively. So bale, based on experience, talaga nakakatulong ang exercises kasi it helped me recall the concepts more often. Pati na rin yung pag-consult ng instructor. Usually mababait naman ang Institute of Math na prof sa pag-consult. Basta magpaalam lang kayo na magko-consult kayo. Pwede siguro sa email, good day, my name is ganito. Tapos, I would like to consult about ito. Tapos napag nyo yung questions nyo. Or, kung pwede sa messenger, you can consult them as well sa messenger. Sabihin nyo lang na, good day, I am ganito. Tapos here are my questions for this consultation. Next, in general, try to start from the basics. So talagang lahat ng mga concepts, from the limits hanggang derivatives, pati na rin sa graph sketching, they always come back to the basics. So bale, what I mean by this, if you feel like memorizing is too much, kunwari, let's say, yung nagtanong last day 1 about sa pag-memorize ng trigonometric functions or let's say general derivatives nila, you can try to derive the concepts on your own. So for example, kung gusto mo hanapin yung derivative ng tan x, you can just derive that by using quotient rule dun sa pag-convert ng sin x into over cos x. So pwede nyo i-ganito, tapos try nyo i-derive on your own. Next, I don't know if this is the last, pero of around 50 to 30 minutes before the exam. Bale, at this point, dapat na sa IM na kayo kasi medyo strict sila sa time schedule. Kung wala ka sa IM, baka hindi ka na ipag-take ng makeup exam, especially hindi valid ng excuse na late kayo dun sa exams. So, if you're able to review beforehand, relax and do nothing. Ease lang kayo. Breathe in, breathe out lang. Tapos, wag nyo nang isipin, wag na kayo mag-overtake kasi sasabak na kayo sa giyera, sa exams. Remove all tenseness from your body. Put your mind at ease so that it can be in your best shape before the exam. So that's it for siguro for the tips before the exams. Ay, may isa pa. So this is very important kasi ang IM hindi pumapayag na umihi during the exam. So beforehand, please umihi na kayo para hindi na kayo mahirapan at saka yung iisipin nyo na ng exams. And do not drink too much water kasi baka mamaya bigla kayo maihi nang wala sa oras. Do every necessary things before going in sa test room natin. Okay, next. Tips during exams. So ito naman yung mga tips habang nagsasagot kayo ng exams. So, still for others, it may work, pero put 2 lines of spacing at the top of your solutions in case there's an assumption you forget to make. For example, if you forget to mention a function is differentiable. So yung mga ganito, for example, let's say f of x equals, let's say, something keme-keme. Tapos kung gusto mo, para ma-double check mo na mabuti, yung domain niya is not covered dito. So you can try to put those 2 lines sa taas. Next, ito pinaka-importante for me. Always skip the hard questions and go for the easy ones first, then go back to the hard questions. You can jumble the order of the items in your blue book so long as your answers and solutions are well labeled. So bale, sa skip the hard questions muna, based on experience, nakakatulong talaga siya. Kasi if you just stuck ka dun sa questions mismo na iti-take, may chance na mas stuck ka dun for too long, tapos biglang nakalimutan mo na may mga questions pala afterwards. So masyado kang ma-overthink dun sa question na yun, and at the same time, baka hindi mo na masagot on time yung ibang question na mas madali pala dun sa question na stuck up ka. Then, jumble the order of the items. Ito yung part na sinasabi na since you're skipping hard questions, you can try to label it as kung ano man yung order na gusto nyo. At saka ano naman may guide yung mga profs pag nag-check na sasagot. Okay, next. Usually, you can write the questionnaire to have a guide. So yes, totoo to. Kasi nung Math 23 exam ko nung Saturday, what I did, kahit hindi to Math 23 in general to, what I did was sinusulat ko sa questionnaire yung mga formulas na kailangan dun sa specific na problem. Then you can just answer it para at least hindi kayo mahirapan. Then, ayun, you can even write your own formulas. Parang may guide sana kayo para dun sa exam mismo. Okay, next. If you do not have correction tape, you can just scribble on the wrong solution and place the correct one right after. So siguro in this step, basta as long as pumapayag yung prof na mag-scribble ka dun sa hindi parang feeling mo mali yung solution mo, you can do this. Thus, if it doesn't fit, ensure the proctors what page you'll be placing your newly corrected solutions so that you won't get deductions. So parang kasunod lang nito yung sa yung tip number 2 na you can jumble the order. Kasi kung hindi nyo na-label yan, that means na i-check agad ng prof, ay, mali pala to. Tapos nung nakita niya, ay, ba't hindi mo sinabi na nandun sa isang solution, tapos mali pala tong solution na sinulat mo. So don't forget palagi to label it. And then, wait lang. Okay, so my last one is tips after. May isa pa pala. So try not to panic. Kaakibat nito yung sa number 2. Calm yourself down and do your best to answer the questions. So bale, ano na kasi, you're taking the exam na. So there's no reason for you to panic bigla kasi lalo na you're gonna be stuck in the problems. Don't overthink that much, parang sinabi ko kanina. So last but not the least, may tips tayo after exams. So una, so kung feel nyo na pwede na kayo umihi since after na to na exams, umihi na kayo para mawala na yung lahat ng mga nararamdaman nyo talaga. Next, you can try to recall what you did in the exam. So, kunwari, let's say, after exams, naisip ko na, tama ba tong solution ko dito sa part na to or hindi? You can try to take that, pero make sure na i-discuss nyo lang siya sa mga kapwa yung ka-exam. Hindi pwedeng sa hindi pa nag-exam. Kasi they will get spoiled. And based sa academic honesty, kineme na you shouldn't discuss anything out during the exams just right after. Kasi it will be a spoiler din kasi dun sa mga nagtetest. And kahit sabihin mong na makeup exams nila will have a different set, just to be safe lang, don't discuss it sa mga hindi pa nagtetake. Next, don't overthink it. Siguro, it's a counterintuitive example dun sa kanina na inisip ko yung problem. Pero para hindi na kayo mangoblema masyado, huwag nyo na lang isipin, is important is tapos na yung exam. Next, celebrate that you have finished the exam. So yes, one important step to for me siguro kasi done na kayo eh. Tapos na kayo sa exam. So what you can do is just relax. You can try to eat with friends, maglaro lang kayo, or bili kayo ng kung ano-ano ng stuff na makakapag-distress sa inyo. And last but not the least, try to manifest the results you want to receive. So, bale, at this point, wala na tayong control dun sa exam since tapos na. So, what we can do is manifest na maging okay ang ating results. Hopefully, and eventually, magiging okay yan. So, I think this is the last. Are there any other questions in general? So, bale, let me check kung meron questions dun sa ating pigeonhole. Tapos kung wala, you are free guys to ask any questions at this point. We still have 30 minutes. Okay, so ayan, may isang question. So wait lang, let me check. Okay, so yung question dito is, sorry, hindi ko napansin kanina. So let me share my screen lang ulit. Okay, so wait lang, balikan ko lang to. So I saw a question here in Pigeonhole. Paano po malalaman yung concavity ng F prime kung ang given po na graph ng F? Graph ng F. Okay. So concavity ng F prime. So siguro let me try to recall. So siguro let's focus on this graph. So concavity ng F prime. So concave up at saka down kung given po ng graph. Bale, ano na lang. Since graph naman to, pinapakita, you can try to check it yourself. So kunwari ganyan, let me annotate. So kunwari ganito yung itsura ng graph, concave down na agad siya. Tapos kunwari, let's say gumanito siya. So this is a point of inflection. So usually yung mga concave up is like this, tas like this. Tas pwede siyang i-combine, pwedeng ganyan. Tas meron din yung mga concave down, usually it's either this form or this form. Tas i-combine nyo parang sad face siya. So ganyan yung itsura usually ng concave up at saka concave up at saka concave down. Okay, so I think that's it. So may isa pa tanong actually dito sa pigeonhole. Does the sign changes when it passes through undefined points? Okay. Actually, not necessarily true to kasi I'll show you in a bit. So kunwari, let's say may graph ka somewhere. Let's say ganyan yung graph mo. Yung black tapos itong may B. So bale, sign changes only applies kapag sign changes only applies kapag from papuntang positive infinity tapos from negative papunta agad sa negative infinity and vice versa, which is shown dito sa ating graph. Ito. So nag-sign change siya bigla dito sa undefined since ayun nga pababa to sa negative infinity, so negative yan. Tapos ito merong positive bigla since that's the nature. So just a heads up, balikan natin tong F prime at saka F prime table. So notice na 'Di ba negative, undefined, tapos may negative. So that's or decreasing siya. So parang ano tawag dito? So decreasing, ibig lang sabihin nagde-decrease yung slope dito, negative yung slope dito sa part na to, tapos negative rin yung slope sa part na to. Pero kung change, ibig sabihin yung slope is negative tapos positive bigla yung slope, like pa-increase na agad siya. So let's say dito, feeling ko pag sa derivative to, yung positive yung hindi nagsa-sign change is kunwari nagsa-sign change is kunwari from this one to this one. Then another one is from, let's say, this one hanggang dito sa part na to. So ganyan yung sa sign change ng F prime. Kung F double prime naman, so balikan natin yung table. Ito, nagka-sign change sa vertical asymptote. Kasi nag-concave down tapos bigla nag-concave up. Hindi siya mag-sign change kunwari double parehas either concave up or concave down sa part. Okay ba sa question? Okay. For may nag-PM sa akin, saan ipopost yung mga slides? Rowie, sorry taas, pero Rowie.
Hello, the slides will be posted tomorrow on the official Facebook page of MBAN 109. Kasama na din sa ipopost bukas is a samplex exam and the answer key to that samplex. So yun.
Ayan, thank you Rowie for that. Okay, so may iba pang questions. Wait pa. In relation dun sa concavity, ay sa question na banggit kanina, what if concavity ng F triple prime yung hinahanap pero ang given lang ay graph ng F. So bale ang concavity only applies sa second derivative. Kasi doon mo malalaman yung concavity niya. The only siguro yung pagkakaintindi ko rito, ang concavity ng F triple prime is kung sa kailan siya concave up or concave down sa F prime. So doon lang ma-apply yung sinasabi niyang triple prime na integral. Okay, so mukhang wala na namang tanong. So guys, may ano pa tayo? We still have 7 minutes. So kung may tanong pa kayo, you can try to ask dito sa pigeonhole natin or doon sa chat. So we are waiting for some more questions. Ang last na question will be at 6 o'clock sa pagkatapos ng ating live stream. Okay, ayan. Ay 5:55 pala. So kung may tanong pa ba sa ibang mga participants sa pigeonhole or dito sa chat, you can try to chat me. Sorry po if it was mentioned, either earlier naglag po kasi ako. But when can we buy the blue books po? Hopefully near IM. Actually, ang blue books po ay meron na sa IM mismo. So I think they cost around 5 to 10 pesos. And usually try to ask your prof kung magpo-provide sila ng blue book kasi usually sila naman nag-i-initiate na bumili ng blue book. So kung hindi sa IMAT, sa ano kayo, sa area 2 kayo bumili. May mga stalls doon like sa mga paprintan gano'n. Doon pwede bumili. Then siguro ito isa sa last question since we cannot accommodate any further questions. Is it possible po na may point of inflection as an asymptote? Binanggit na to kanina ng DM na hindi kasi based dito sa graph, kahit sabihin mo na magko-concave down siya dito sa 1 tapos concave up dito, technically speaking, ang point of inflection is a point specifically dito sa graph. So understandable pa kung kunwari ganito yung graph niya, tapos ito ang point of inflection mo. Pero kasi sa case na to, may vertical asymptote tayo, so talagang hindi siya magiging point of inflection. So ito, hindi siya point of inflection kasi the point doesn't exist in the part na to, kahit sabihin mo na concave down, concave up siya. That's a condition for this one. Okay, so I think that's it. So yeah, we may now stop the live stream.